Hello viewers, welcome to my channel. I'm Hasham. Last three videos I have explained you about transportation problem. Very important topic in operation research. Transportation plays a very important role in any economy and for every business because the goods have to be transported from the place of production to the place of consumption. So we have different points of origin and points of destination. So how the goods should be transported from different origins to different destinations so that the transportation cost should be minimum. That is the transportation problem. This type of problems will be solved by applying the technique of operation research. Now, for finding out the solution to this transportation problem, we have two stages. The first stage is finding out the initial basic feasible solution, IBFS. After finding out initial solution, then we have to modify, improve, then we can get the optimum solution. So first IBFS, next optimum solution. So for finding out the initial basic feasible solution, I have already explained you in detail in the previous videos. Three methods are there. First, northwest corner rule. Second, least cost method. And third one is Vogel's approximation method, VAM. So out of these three methods, the simplest method is the northwest corner rule. So in this video, I'm going to explain you two problems on northwest corner rule and two problems on least cost method. So before starting the problem, I suggest you be perfect on the concepts which are being used in transportation problem. For that, watch all the three theory videos which I have already uploaded. So go to the playlist of my channel, select the subject operation research. Select the videos of transportation problem. Watch the complete video. Be perfect about the concept. Then you can come to the problems. So before starting the problem, I expect my viewers to have a printout of the problems which are given in the link under my description. See the problem. First problem I am reading out. Find the initial basic feasible solution to the following transportation problem using northwest corner rule. So specifically given in the problem, we have to apply northwest corner rule. Now the table is given, transportation table is given. Factories are the origin. That means the goods are transported from factory and warehouses are the destination. So three factories, F1, F2, F3 and four warehouses, W1, W2, W3, W4. The table is given. The total supply from each factory, F1 is 7 units, F2 9 units and F3 18 units. And the total of the demand, W1 is 5, W2 is 8, W3 is 7, W4 is 14. The total is 34. That means the total supply and total demand both are equal, 34. That means the problem is a balanced problem. Now here the values 19, 70, 40 is given. What does this mean? It means the transportation cost per unit. For example, when 1 unit is transferred from F1 to W1, the cost is 19 rupees. If you transfer 1 unit from F1 to W2, it will be 30 rupees. F1 to W3, 50 rupees. F1 to W4, 10 rupees. So all the values are given costs. That is the transportation table. Now how to find out the IBFS by northwest corner rule? See here. Finding the IBFS by northwest corner rule. Factories F1, F2, F3, warehouses W1, W2, W3, W4. Factory capacity and warehouse requirement. Whatever is given, that I have written in the table. And the costs 19, 70, 40. These costs I have shown on the upper right corner. This upper right corner shows the cost. I have not taken in the middle. Because in the middle, we have to give the allocations. How many units to be transported. That we are going to take in the middle. So upper right corner, you write down the costs. All the costs which are given in the problem. So we are given the supply. That means 7 units from F1, 9 units from F2, 18 units from F3. And W1 requirement 5, W2 requirement 8, W3 7, W4 14. If you add up 5 plus 8 plus 7 plus 14, you will get 34. 7 plus 9 plus 18, you will get 34. It's a balanced problem. Now, how to find out the IBFS by northwest corner rule? Northwest means upper left corner. Upper left corner. So this is the upper left corner, right? From there, we have to start the allocations. We have to start the allocations from the first cell and come to the right side last cell. Like this, I have to come down, right? First cell. What is the maximum allocation I can make in this cell? Minimum of total supply or total demand. The total supply is 7 units, whereas total demand is 5 units. Whichever is less. The row total is 5 and the column total, the row total is 7 and the column total is 5. Whichever is least, 5 is least. So I am allocating 5 here. I am allocating 5. After allocating 5, you have to cancel this total 5 units. The whole 5 units I have allocated here. So 5 minus 5, 0. So here 5 minus 5, 0. Here the total was 7. 7 minus 5 remains 2. Remains 2. When the column has become 0, block the column. Like this, you have to block the column. That's all. Now we have to come to the right side, this cell. Because from first cell, I have to come to the last cell. So this cell. In this cell, the row total is 2 and the column total is 8. Whichever is less, 2 or 8. 2 is less. So I am allocating 2 here. 2 minus 2, 0. 8 minus 2, 6. When the row has become 0, block the row. This row will be blocked. Now I will come down from 2. I will come down here, this cell. In this cell, row total is 9, column total is 6. Whichever is less, 6 is less. So 6 I am allocating here, 6 minus 6, 0. 9 minus 6 is 3, right? This column has become 0, so I am blocking the column. Now I will move to the right, this cell. The row total is 3, column total is 7. So 3 is less. So I am allocating 3 here. 3 minus 3, 0. 7 minus 3 is 4. This row has become 0. So I am blocking the row. Next, I'll come down. From here, I have allocated like this. Now I am coming down. This cell. Row total 18, column total 4. Whichever is less, 4 is less. So I have allocated 4. 4 minus 4, 0. 18 minus 4 is 14. Last, only one unoccupied cell is left. Row total 14, column total 14. So I will take 14 here. This 14 minus 14, 0. Here 14 minus 14, 0. That's all. I have made all the allocations. This is called northwest corner rule. This is called northwest corner rule. We have to start the allocation from the first cell and end the allocation at the last cell. That's it. Allocations are completed. Now confirm whether all the supply and requirement are zeros or not. 0, 0, 0. Here also 0, 0, 0, 0. All has become 0. That means correctly we have allocated. Right? Now finding out the transportation cost. The first allocation is F1 to W1. First allocation F1 to W1. F1 to W1, how many units are allocated? 5 units. And what is the cost per unit here? 19 rupees. Similarly, F1 to W2. F1 W2. F1 W2, 2 units, 30 rupees. Then F2 W1. F2 W2. F2 W2, 6 units, 30 rupees. 6 units, 30 rupees. F2 W3. F2 W3, 3 units, 40 rupees. 3 units, 40 rupees. Then F3W3. F3W3. How much? 4 units, 70 rupees. 4 units, 70 rupees. Last one, F3W4. F3W4. How many units? 14 units, 20 rupees. 14 units, 20 rupees. That's all. So I have taken all the allocations, units and per unit. Now we have to find out the total cost. 5 into 19, that comes to 95. Here I will take 95. 2 into 30 is 60. 6 into 30 is 180. 3 into 40 is 120. 4 into 70 is 280. 14 into 20, that is 280. That's all. Now simply take the total. 95 plus 95 plus 60 plus 180 plus 120 plus 280 plus 280. It comes to 1015. 1015. That's all. Verify again. 95 plus 60 plus 180 plus 120 plus 280 plus 280. It comes to 1015. This is the total cost of making these allocations. That's all. First problem on northwest corner completed. Now second problem. Determine the initial basic feasible solution to the following transportation problem using northwest corner rule, where OI and DJ represents ith origin and jth destination respectively. So O stands for origin and D stands for destination. So O1, O2, O3, 3 origins are there and destinations are D1, D2, D3, D4. Supply is given, demand is given, same transportation table is given. So I have prepared the table exactly same way. Origin O1, O2, O3, destination D1, D2, D3, D4. Supply, demand. The supply are 14, 16, 5. 14, 16, 5. And demand is 6, 10, 15, 4. Total 35. If you add up 6 plus 10 plus 15 plus 4, 35. 14 plus 16 plus 5, 35. Balanced. And all the costs which are given in the problem, I have written in the upper right corner. Upper right corner, because in the middle we are going to allocate, right? Again, exactly in the same way what we have done in the first problem, make the allocation according to northwest corner rule. First cell I am going to allocate, to the last cell I am coming, right? First cell, what is the row total and what is the column total? The row total 14, column total 6, whichever is less. 6 is less. So I am allocating 6 here. So 6 minus 6 will become 0. And 14 minus 6 is 8. 14 minus 6 is 8. Now here the column has become 0. Whichever will become 0, block it. The column will be blocked. Like this, I am blocking the column. That's all. Now I am moving right side. This cell. What is the row total here? 8. Column total 10. Whichever is less. 8 is less. So I am allocating 8 here. This 8 minus 8 will become 0. 10 minus 8 will remain 2. Now row has become 0. So block the row. Block the row. Whichever has become 0, that you have to block. Sometimes column will become 0. Block the column. Sometimes row will become 0. Block the row. Or now I am coming down. From 8 I am coming down. What is the row total here? 16. Column total 2. Whichever is less. 2 is less. So I am allocating 2 here. 2 minus 2, 0. 16 minus 2 is 14. Now column is blocked. Right? Now I am coming to right side. This cell. Row total 14, column total 15. Whichever is less. 14 is less. So I am allocating 14 here. So 14 minus 14, 0. Here 15 minus 14, 1. So this has become 0. So block the row. The row is blocked. Now I am coming down. this cell. Column total 1, row total 5. Whichever is less, 1 is less. So 1 minus 1, 0. 5 minus 1, 4. Lastly, only one cell is unoccupied, blank. Right? What is the row total here? 4. Column total 4. If I take 4 allocations here, this will become 0. This will become 0. Now you can confirm all the rows has become 0 and columns also has become 0. That's all. Our allocations are completed. IBFS according to northwest corner rule. Like this I am going from here to here, here down, then I am moving right, then down, then I am moving right. That's all. Now allocations. We have to give the allocations. First allocation is O1 to D1. See here. O1 to D1. How many units? 6 units, 6 rupees. Then O1 to D2. O1, D2. 8 units, 4 rupees. Then O2, D2. O2, D2. 2 units, 9 rupees. O2, D3. O2, D3. 14 units, 2 rupees. O3, D3. O3, D3. 1 unit, 6 rupees. Last one, O3, D4. O3, D4. 4 units, 2 rupees. 4 units, 2 rupees. That's all. Now we have to multiply the units with the cost. 6 6 36. 8 4s 32. 2 9s 18. 14 2 28. 1 6 6 4 2 8. That's all. We have calculated. Now 36 plus 32 plus 18 plus 28 plus 6 plus 8. It comes to 128. That's all. So 2 problems I have explained on northwest corner rule. Now remaining 2 problems I am going to explain about the least cost method. See the problem number 3. Solve the following transportation problem by least cost method. Second method. Warehouses W1, W2, W3, W4. So 4 rows are there. And dealers are the destinations. D1, D2, D3, D4, D5. So 5 columns. 5 columns and 4 rows. The supply from the warehouses are quantity available 20, 30, 15, 30. And the requirement at the dealers are how much? 46, 8, 18, 6, total 78. It's a balanced one. Total supply, total demand, both are equal. And the transportation costs are given 3271. To transport 1 unit from W1 to D1, 3 rupees. From W1 to D2, 4 rupees. Like the transportation costs are given. So here you can see the table. Finding the IBFS by least cost method, LCM. Warehouses W1, W2, W3, W4. And the dealers D1, D2, D3, D4, D5. Quantity available, quantity required. And whatever is given in the problem, same thing I have taken 46, 8, 18, 6. Here 20, 30, 15, 13. Total 78 balanced. And the costs I have taken at the upper right corner. We have not written the cost in the middle because in the middle we are going to allocate. Now, one of the drawback of least cost method, northwest corner rule is we have not considered the cost. Simply we go on allocating the values from the left corner, upper left corner to right bottom corner. Right? Like this only we are allocating without considering the cost. That is a drawback. Because our objective is to reduce the cost. So cost must be considered while calculating IBFS. The drawback of northwest corner rule, that one. To overcome that, least cost method. In least cost method, we consider the cost. Now how to make the allocation in least cost method? Select the least cost among all the costs. All these are the costs. 3, 2, 7, 1, 4, 10, 11, 0. All these are the costs. Whereas the quantity is in units. Quantity available and quantity requirement is in units, whereas all these are costs. Select the lowest cost. In this table, you can see the lowest cost is 0. You can see here 0 is here and 0 is here. So in two cells, the lowest cost is 0. Select any one of the 0, either this 0 or that 0. Any one of the 0 you select. So I am selecting this 0. So how much allocations I can make in this cell? Row total 13, column total 6. Whichever is less. 6 is less. So I am allocating 6 here. So 6 minus 6, 0. 13 minus 6 is 7. 13 minus 6 is 7. The column has become 0. The column should be blocked. This column is blocked. Column is blocked. That's all. Now whichever column is occupied or blocked should be ignored. Now in the next iteration, we are not considering all these things because these three cells are blocked and this cell is occupied. Now leaving this, again you find out what is the minimum cost. Again you will see the minimum cost is 0. So in that 0, make the allocations. What is the row total here? 30. Column total 8. Whichever is less. 8 is less. So I am allocating 8 here. So this will become 0. 30 minus 8 is 22. The column has become 0. So column is blocked. This column is blocked. That's all. Now leaving this remaining cost, in the remaining cost which is the lowest cost. See carefully, after 0 the lowest cost is 1. 1 is here. There is no other one. 1 is the lowest cost. So allocate in this cell. The row total is 7 and the column total is 40. Whichever is less. 7 is less. So here I am allocating 7. So 7 minus 7 will become 0 and 40 minus 7 will remain 33. The row has become 0. So block the row. I am blocking the row like this. Over. Now for the remaining cells, again find out the minimum cost. The minimum cost is 2. You can see here 3, 2, 7, 8, 5, 40. 8, 8, 3. The minimum is 2. Now allocate in this 2 cell. Right? What is the column total? 33. Row total 22. 22 or 33, whichever is less. 22 is less. So I am allocating 22 here. So 22 minus 22 will become 0 and 33 minus 22 will remain 11. Row has become 0. Row has become 0. So block the row. This row I am blocking. That's all. Now remaining costs are, you can see here 3. 3, 8, 8, 7, 40 and 3. The lowest cost is 3. But it is occurring twice. 3 is here. 3, 7, 43, 8, 8. So 3 is occurring twice. So we can select either this 3 or that 3. If we select this 3, how much allocations we can make? 11. If we select this 3, 11 allocations. If we select this 3, only 6 allocations we can make. So wherever we can give more allocations, that should be selected. If we select this 3, 11 allocations we can get. If we select this 3, only 6 allocations we are getting. So better to select this one. So here 11 allocations I am making. So 11 minus 11, 0. 20 minus 11 is 9. So this has become 0. So block this column. Or now only 4 unoccupied cells are there. 8, 8, 43. The lowest cost is 3. Now I am filling the 3. This 3 if we select, the column total 6, row total 15. So I am selecting this 6. 6 minus 6, 0. Right? Then 15 minus 6 is 9. This has become 0. So block it. That's all. Now still 2 more unoccupied cells are there. This is 8 and this is 40. So first we fill up 8. So the row total 9, column total 18. So here I am allocating 9. So 9 minus 9, 0. 18 minus 9 is 9. That's all. Now what do you observe? Only one unoccupied cell is left. And the row total is 9, column total is also 9. So I'm allocating 9 here. This will become 0, this will become 0. That's all. All the cells either occupied or blocked. All the cells. And you can see all has become zeros. The row total and column total, everything has become 0. Correctly we have allocated. Now allocations units. First one W1 D1. W1 to D1. How many units? 11 units, 3 rupees. Then W1 to D4. W1 to D4, 9 units, 8 rupees. Then W2 to D1. W2 D1. 22 units, 2 rupees. W2 D3. W2 D3. How many units? 8 units, 0 rupees. Then here W3 D4. W3 D4, 9 units, 40 rupees. 9 units, 40 rupees. W3 D5. W3 D5, 6 units, 3 rupees. Then W4 D1. W4 D1, 7 units, 1 rupee. And W4 D2. W4 D2, 6 units, 0 rupees. That's all. So we have taken all units and cost per unit, multiply 11 into 3, 33. 9 into 8 is 72. 9 into 8, 72. Then 22 into 2, 44. 8 into 0, 0. 9 into 40, 360. 9 into 40 is 360. 9. Then 6 3s are 18. 7 into 1, 7. 6 into 0, 0. That's all. Now add up. 33 plus 72 plus 44 plus 360 plus 18 plus 7. It comes to 534. That's all. This is the first problem on least cost method I have done. Now, see the fourth problem. Problem number 4. Obtain an initial feasible solution to the following transportation problem using matrix minima method. Matrix minima method means least cost method. O1, O2, O3, 3 origins and destinations are D1, D2, D3, D4. Supply 6, 8, 10 and demand 4, 6, 8, 6. So exactly same table I have drawn. O1, O2, O3, D1, D2, D3, D4. Supply is 6, 8, 10. Demand is 4, 6, 8, 6. Total comes to 24 balanced. The total of rows and total of columns are same. Then the cost, unit cost are given 140. Right? Now we are following least cost method. Which is the minimum cost in this table? 0 is the minimum cost, but it is occurring twice. Here 0, here 0. Select any one of the 0. I am selecting this 0. So the row total 10, column total 4. So 4 units I have selected. 4 minus 4, 0. 10 minus 4, 6. The column is blocked. That's all. The next minimum cost is 0. Again 0. This 0. Row total 8, column total 6. So 6 allocations I have made. 6 minus 6, 0. 8 minus 6, 2. This has become 0. It is blocked. Column is blocked. Next minimum cost is 2. You can see here minimum cost is 2. But 2 is occurring 4 times. 1, 2, 3, 4. 4 times 2 is occurring. So select arbitrarily any one of the 2. Suppose if we select this 2, what will happen? If we select this 2 row, now you can see the remaining 2 cells, the minimum cost is 2. So select this 2 and make the allocation. So row total 2, column total 8. So 2 is minimum. So 2 minus 2, 0. 8 minus 2, 6. Finally, only one unoccupied cell is left. The row total is 6. and column total is also 6. So make allocation 6. This will become 0. This will become 0. That's all. Now you can confirm all the column totals 0 and row totals also 0. And all the cells are either occupied or blocked. That means we got the solution. Now we have to find out the allocation and total cost. The first allocation O1 to D3. O1 to D3. How much? 6 units, 3 rupees. Then O2 to D3. O2 to D3. 2 units, 2 rupees. O2 to D4. O2 D4. 6 units, 0 rupees. And O3 D1. O3 D1. 4 units, 0 rupees. O3 D2. O3 D2. 6 units, 2 rupees. That's all. Now multiply. 6 3s are 18. 2 2s are 4. 6 0s are 0. 4 into 0, 0. 6 2s are 12. So here we are having 18 plus 4 plus 12. It comes to 34. 34 is the total cost. That's all. So in this video, 4 problems I have explained. First 2 problems on northwest corner rule. This method of finding out the IBFS by northwest corner rule is very simple. Without considering the cost, we go on making allocations from the upper left corner to the bottom right corner. From here to here, we go on making the allocations without considering the cost. It's a simple method of finding out the IBFS. But the drawback of this method is, after finding out IBFS, it will be very much time consuming to find out the optimum solution. Optimum solution will be very far away from IBFS. Lot of time will be wasted. That is a drawback of this northwest corner. The second method is least cost method. In this least cost method, we are considering the cost. We are making the allocation on the basis of cost. But again, the drawback is many iterations are required after completing IBFS to find out the optimum solution. Then which is the best method? In the next video, inshallah, I am going to explain you the third method, that is Vogel's approximation method, VAM. Now, in examination, if it is specifically asking you to find out IBFS by northwest corner rule or least cost method, then only you follow. Otherwise, if in the problem it is asking you find out the IBFS, not mentioned which method we have to follow, then always go for VAM. Because VAM method is much superior than this least cost method or northwest corner rule. So inshallah, we will continue the next problem, that is IBFS through VAM, in the next video. If you want the perfect knowledge, watch all the videos from beginning till end. Don't skip in between. And always make notes whatever I am explaining. Don't simply listen and watch the video. Always maintain the notes. Keep a calculator, pen, notebook ready while watching the video. So if you are satisfied, give a like to the video. Share my channel among your friends, among your group, so that more students can watch the video and enhance the knowledge. Give your comments. Subscribe my channel if you have not yet subscribed. And buy the super thanks which is given below my video. Inshallah, we'll continue in the next video.